Welcome to our review on atom economy. The first thing we need to know then is what is atom economy? When we refer to atom economy, we're talking about a measure of how many atoms from our reactants actually make the desired product, so the product we want to make. If we have a low atom economy, then that tells us that there's only a very small number of atoms in our reactant that end up in the product we wanted to make. Whereas if we've got a high atom economy, then many of the atoms in our reactant end up in our desired product. Before we go on to calculating atom economy, we need to have a little bit of a refresher about how to calculate the relative formula mass. So if you remember, to calculate the relative formula mass of a chemical, we need to use the periodic table, which, if you remember, is that random piece of paper that some of you may not turn over in the exam. So that second piece of paper separate to your question booklet, make sure you flip it over because the periodic table is there for you. So you use the periodic table to find the mass of each atom and then just add it up. That's all we've got to do here. So I've given you 4 examples underneath there just to remind you of a couple of things. First one, to work out our water, the formula is H2O. The little 2 there only applies to the hydrogen. So 2 times the atomic mass of hydrogen, which is 1, plus oxygen, 16, gives us 18. Sodium chloride, we know that Na is one element because every element starts with a capital letter. The second will always be lowercase. So we've got sodium chloride, Na, sodium, Cl, chlorine. So look those up, add them together. If we've got brackets, like we do on number 3, then that little 2 outside the brackets tells us to multiply everything inside the brackets by 2. So we've got 1 aluminium, but 2 oxygen and 2 hydrogen. The only other one that they could include, if they were being particularly mean, is a hydrated compound, which is what we see in number 4. All that little dot means is that it's all part of the same compound. So just ignore that in reality and just treat it as if it was all the same thing. So we've got 2 sodium, 1 carbon and 3 oxygens in our sodium carbonate, and then we've got 10 water molecules. So we've got 2 hydrogens there, which we're going to times by 10, so 20 hydrogens, and 10 times our 1 oxygen gives us 10 oxygens. That's about as complicated as they could give you. So just remember, the little dot there just means it's hydrated, so there's water molecules attached, and the number in front of the water tells you how many there are. So in order to calculate the atom economy, we've got to remember this formula. They're not going to give this to you on the exam paper, so you do have to memorize it. So atom economy is the sum of the relative formula mass of the desired product divided by the sum of the relative formula masses of all products, and then we times it by 100 because we give it as a percentage still. The kind of question they could give you is in the second box there. Hydrogen can be produced by reacting methane with steam. You get your balance symbol equation for it, and then calculate the atom economy of the process, giving your answers to 3 significant figures. First thing, pick out the important information. So this is where you can highlight in the question, you can underline, circle, whatever's going to help you to recall the important bits without having to keep rereading it. So we're trying to produce hydrogen. So hydrogen is our desired product there. And the other thing we need to bear in mind when we give our answer is to give it to 3 significant figures. If you don't do that, you're throwing away one of the marks for these calculation questions. The next thing we've got to do is to calculate the relative formula mass of each of those products. So remember, products are on the right hand side of the arrow. So we've got 2 products in this case, CO, which is carbon monoxide, and hydrogen. So look up on the periodic table carbon, which is 12, and oxygen, which is 16, and add them together to give us 28. Do the same for our hydrogen, remembering to times it by 2 there to give us our relative formula mass of H2 of 2.0. The next step is to use our balanced equation and the atom economy formula to work out the overall atom economy. So if you remember, it's the relative formula mass of our desired product divided by the relative formula mass of all products times by 100. So our desired product is hydrogen, and we've just worked out that one hydrogen molecule has a mass of 2.0, but there are 3 of them from the balanced equation. So we need to do 3 times 2.0 and divide that by the mass of all of our products. So carbon monoxide was 28, and we've got to add that onto our 3 hydrogens as well. So 28 plus 3 times 2.0 gives us our total for all of the products. Then whatever that works out to be, times it by 100, and that gives us the answer of 17.6% to the 3 significant figures it told us to use in the question. So make sure that when you're setting this out on the exam paper, you show each step of your working, because even if for some reason you fail to use a calculator or fail to copy off the screen or you can't round, all of these are things I've seen some of my students do in the past, at least you're only throwing away 1 or 2 marks as opposed to the whole lot. If all you do is write down an answer on the answer line, if it's wrong, you've got nothing. If you've shown every little step, then you get everything right until the tiny error. So make sure you show all of your working. The last thing to bear in mind when we're talking about atom economy is the following statement, that the higher the atom economy of a process, the more sustainable and greener it is. And what we mean by this is that if we've got a really high atom economy, that means that we're using virtually all of the atoms from our reactants to form our desired product. We're not making a whole load of other byproducts which could be toxic, etc. So that means it's a much greener process and it's a much more sustainable process as well. Hopefully at the end of this video you can define what atom economy is, you can recall the formula to calculate atom economy, and you can calculate the atom economy of a reaction when given information in a question.